This is geometry lesson 8-4. 8-4. We've got 3 slides today. Let's start off on this one. We've got a kind of a tree chart, I guess I'll call it. And at the top of the tree chart is a parallelogram. Remember, a parallelogram, it's got 5 properties that we talked about. The first one was that the whole reason they call it a parallelogram, opposite sides are parallel. Second, opposite sides are congruent. Opposite angles will be congruent. Consecutive angles are supplementary. And the diagonals bisect each other. True, those 5 properties are true for all parallelograms. Now let's look at a special parallelogram. It's the rhombus. It's got all 5 of those properties, plus, in addition, it has 3 additional properties. The first one you might remember is opposite sides are congruent. All 4 sides are the same in a rhombus. Also, the diagonals are perpendicular. Let's draw them in. Here we go. Let's draw. This one will be the black diagonal. Okay. And let's do this one in here as the red diagonal. Look at this. Not only do they bisect each other, that's true for all parallelograms, but in addition to that, they're perpendicular. They make right angles. They make right triangles. Also, the third one, it says the diagonals bisect opposite angles. So what we're talking about is, look at the red. Look at the red diagonal. It's vertical. It cuts this angle in half. It cuts this angle in half. Now look at the black diagonal. It's the horizontal one. It'll cut this angle over on the right in half. It'll cut the angle on the left in half. So it's got all the properties of a parallelogram plus 3 additional ones. What I like to say is all rhombuses are parallelograms, but not all parallelograms are rhombuses. Okay? Let's unveil our next special parallelogram. It's a rectangle. Okay? It's got 2 special properties. It's got all the properties of a parallelogram, plus it's got 2 additional properties. First of all, it's got 4 right angles. Second of all, the diagonals. The diagonals are congruent. That's not always true. Let's draw those in. Here it is. The 2 diagonals are exactly the same length. Notice over in the rhombus, that's not necessarily true. In this rhombus I drew, the red diagonal is not the same length as the black one. But in a rectangle, yeah, the diagonals will be congruent. So what I like to say about rectangles, all rectangles are parallelograms, but not all parallelograms are rectangles. Okay, here we go. Let's unveil the father of all parallelograms, I guess. It's the square. A square has all of these properties. It's got all 5 of the properties of an ordinary parallelogram, plus it's got the properties of a rhombus, because a square is a rhombus. It's got all the properties of a rectangle, because the square is a rectangle. Let's start drawing them in here. First of all, just like a rhombus, all 4 sides are the same. Just like a rectangle, all 4 angles are the same. Just like a rectangle. Let's go here. Just like a rectangle, the 2 diagonals, they're the same length. Just like a rhombus, the 2 diagonals are perpendicular. They form right angles. They form right triangles. And also like a rhombus, they bisect the angles in the corner. They bisect. They cut in half the angles in the corner. Now, think about it. You got a square, so you got 90 degrees in every corner. You cut that in half, yeah, you're going to get 45s all over the place. If you've got diagonals in a square, you got 45s all over the place. There we go. Nice. What I like to say about a square is all squares are parallelograms, but not all parallelograms are squares. And all squares are rhombuses, but not all rhombuses are squares. All squares are rectangles, but not all rectangles are squares. Let's go to our second page. On page 2, we've got a rhombus. So right away we know it's got all the properties of a rhombus. It's got all the properties of a parallelogram, because it is a parallelogram. Now, we want to find the perimeter, and we want to find this side, find this distance right here. Right here, we want to find that distance, QE. Well, first of all, if we want to find the perimeter, one nice thing about a rhombus is all the sides are the same. Another nice thing about a rhombus, the diagonals. Back on page 1, let's go look back real quick. About a rhombus, the diagonals are perpendicular to each other. So we've got 90 degrees. We've got 4 right triangles, and they're actually all the same. Okay, now, it is a parallelogram. So what do the diagonals do on every parallelogram? The diagonals do what on every parallelogram? They bisect each other. This one kind of going, the yellow one here, that yellow diagonal, it cuts this one in half. The long one cuts the short one in half. So here right away we know, hey, if this is 10, this is 10. Let's concentrate on just this one triangle. We'll call it the green triangle right there. I tell you what, first thing I want to do, I want to find this side right here, QW. Let's find QW. Once I got one side, I multiplied by 4 and I got the perimeter. So let's find that side now. I'm going to put my eye on the 70. If I have the 10, that's there, I want to find QW. Think about the trig function that you're going to use. I have the opposite, that's the 10. I want the hypotenuse, that's QW. Opposite hypotenuse, that's sine. Let's set it up. Sine of where your eye is, so sine of 70 equals opposite on top, that's the 10, over the hypotenuse, that's QW. Let's get sine of 70. First of all, check our mode. We're looking good in degrees. Okay. Hey, we got sine of 70. Sine of 70, 0.9396 equals 10 over QW. Neumeier, unknown on the bottom. What do? Yeah, you got it. The Toby switch. Here we go. Unknown on the bottom. That's when you do the Toby switch. QW equals 10 over 0.9396. QW equals, here we go, 10 divided by 0.9396. Nice, at 1064. There we go. Hey, Neumeier, you could do some rock climbing. That's kind of a solitary sport. So you don't have to get, any social distancing, no problems on that one. Okay, here we go. So that side is 1064. Just throw that in there. 1064. Every side is 1064. Here we go. 1064. 1064. There we go. Our perimeter. We've got 4 sides. Each one is 1064 for a grand total of, there it is, 4257. We've got the perimeter. Now, let's find the length of the yellow diagonal. What we first need is QK. We need the part just right in here. Right in there. Well, that's part of our triangle. I'll tell you what, we could do trig, we could do Pythagorean theorem. I'm going to do trig on this one. From the eye, the 10 is the opposite, The red side, the QK, that's adjacent. Opposite, adjacent. Opposite, adjacent. That's tangent. Let's set it up. Hey, tangent of where my eye is. So tangent of 70 degrees equals opposite 10 over the adjacent QK. Okay, let's do tangent of 70. Nice, there it is. 2.7474 equals 10 over QK. Once again, unknown on the bottom. We do the switch. QK equals 10 over 2.7474. Here's QK. Let's see what we've got here. We've got 10 divided by 2.7474. Okay, looking good. Let's go 364. 364. This right here is 364. Well, so is this. 364 for a grand total for that one times 2. Boom. Let's go with 728. 728. That's what they wanted right there. Okay, we got the perimeter, we got QE, we're looking good. Let's go to the last slide. Last slide, it is a square, it's got a lot of properties. We want to find the diagonal FH, and let's do that first. What do we know about a diagonal in a square? First of all, is it a parallelogram? Yes, they bisect each other. Second of all, is it a rectangle? Yes, they're the same length. So on a square, your diagonals are going to be like this. That equals that. That equals, they're all the same. 4, 4, 4. There we go. So FH is just 8. We got that. The next one, look at the angle. Go start at FHJ. It's going to be at the middle one, the H. FHJ. This is the angle we're looking for. Well, we know that there's 90 degrees in every corner. And what do the diagonals do? It's a rhombus. A square is a rhombus. The diagonals bisect every angle. So we got 45 here, 45. We got 45s all over the place here. Here we go. Let's get back to that. There we go. 45 right here, 45 right here. There we go. We got 45s all over the place. So that angle right there is 45 degrees. Let's see what else they want. FJ, the side. Okay, so here's what they want. Okay, couple ways to do it. I do know this. In a rhombus, the diagonals are perpendicular to each other, and a square is a rhombus. So we've got right angles right in the middle. So if you want to, you could look at this triangle right here. Okay, if you want to do Pythagorean theorem, fine. To get the side, you could do that. Or you could do a 45, 45, 90. Let's do Pythagorean theorem. That's pretty quick on this one. Here it is. 4 squared plus 4 squared equals FJ squared. 16 plus 16 equals FJ squared. 32 equals FJ squared. Root, here we go. Side FJ, the square root, we've got the square root of 32. Boom, that's going to be 566. 566 here. What's nice about a square? All the sides are the same. We've got 566 here. 566 here. 566 here. Perimeter, here we go. 4 times 566. Our perimeter of our square, there it is, 2262, 2262, and that's our lesson for lesson 8-4. Have a good one.